This could be the most important health briefing you come across this year. So stop scrolling for a moment and pay attention. What you are about to hear is not random fear or online speculation. It is based on recent scientific reports and global health alerts that most people are not fully aware of yet. We are talking about Ebola, a virus that the media often reports on briefly during outbreaks and then quickly forgets until it reappears again in a more dangerous context. And right now, according to the World Health Organization, there has been a declared global health emergency, with confirmed cases appearing in regions that were previously considered safe. This is not designed to create panic, it is about awareness, because understanding the facts can genuinely make a difference in how people respond and protect themselves. One of the most concerning findings from recent research published in 2024 by the WHO in collaboration with scientists from the London School of Hygiene and Tropical Medicine is that adults over the age of 60 face significantly higher risk when infected. The data suggests mortality rates in older adults can be nearly 40% higher compared to younger groups between 25 and 40 years old. That number is not small or theoretical, it represents a real difference in survival outcomes. Yet, despite this, most public health messaging does not specifically address older populations in detail. That gap in communication is one of the reasons this information matters, especially for families and individuals who fall into higher risk age groups. Later in this video, there is a real case you will hear about: a 67-year-old man named Gerald from a rural area in western Uganda who survived an Ebola infection under conditions where most expected the outcome to be very different. His case is not presented as something miraculous or unrealistic, but as a medically observed example of how the body's condition before infection can influence recovery. The details of what his medical team documented offer important insights for anyone concerned about immune health, particularly in later life. Stay with this because it connects directly to what we understand about resilience and vulnerability. Before going further, there is something I want to ask you, and I do genuinely read responses from this community. How old are you? And have you or someone close to you ever experienced the impact of a viral outbreak, whether COVID-19, influenza, or another infection? The reason I ask is simple. It helps understand how different age groups and experiences relate to this information. Because health risks are not the same for everyone, and context matters. Now, to understand Ebola properly, we need to move away from assumptions and focus on what it actually is. Most people recognize the name, but not the science behind it. Ebola belongs to the Filoviridae family of viruses, a group known for their unusual and distinct shape. Under high-powered electron microscopes, instead of appearing as simple round particles like many viruses, Ebola often looks like long, twisted filaments, sometimes curved, sometimes stretched like thin threads. It is one of the most visually distinct viruses ever observed in laboratory research. The virus was first identified in 1976 during two separate outbreaks that occurred almost simultaneously in different parts of Africa. One was near the Ebola River in what is now the Democratic Republic of Congo, and the other in Zara, Sudan. These were independent outbreaks caused by the same virus, which immediately signaled something unusual and dangerous to researchers at the time. Since then, scientists have identified 6 species of Ebola virus, but one strain in particular has been responsible for the most severe human outbreaks. That strain, formerly known as Zaire Ebola virus, has been associated with the largest and most devastating outbreak in recorded history, the West African epidemic between 2014 and 2016. During that period, more than 28,000 people were infected and over 11,000 lost their lives. To understand the scale, that single outbreak caused more deaths than all previous Ebola outbreaks combined. Even with global intervention, massive funding, and coordinated international response, the virus still spread widely before being brought under control. What makes Ebola particularly concerning is not only its potential fatality rate, which can range from 25% to as high as 90%, depending on the strain and medical support available, but also the way it affects the body once infection begins. Unlike many viruses, Ebola does not behave in a slow, predictable manner. It can escalate quickly, and the biological processes it triggers inside the human system are severe and complex. Understanding that process is essential because it explains why this virus has remained such a serious public health concern for decades. Now that we understand where Ebola comes from and why it is considered such a serious virus, the next critical question is how it actually spreads, because this is where a lot of misunderstanding exists and where fear has often replaced accurate information. Ebola does not spread in the same way as influenza or COVID 19. It is not an airborne virus. That means you cannot catch it just by being in the same room, breathing the same air, or passing by someone who is infected. This single fact changes how we think about risk completely because it limits transmission to specific direct conditions rather than casual contact. Ebola spreads through direct contact with the bodily fluids of an infected person. This includes blood, saliva, sweat, vomit, urine, feces, breast milk, and semen. The key point is not just contact, but contact in a way that allows the virus to enter the body through the eyes, nose, mouth, or broken skin. That is how infection begins. This is also why Ebola outbreaks are so heavily centered around close caregiving situations, hospitals, and traditional burial practices, where physical contact with the body is part of cultural or emotional expression. One of the most difficult aspects of outbreak control is exactly this human element. In many communities, especially in parts of Africa where outbreaks have historically occurred, washing and touching the body of a deceased loved one is an important cultural practice. But during Ebola outbreaks, this act can unintentionally become a major transmission route. Public health workers often face the extremely sensitive challenge of asking families to avoid these practices, which creates emotional distress and cultural conflict, even though it is necessary for preventing further spread. Animals also play a significant role in how Ebola enters human populations in the first place. Scientists believe the natural reservoir host of the virus is fruit bats from the Pteropodidae family. These bats can carry the virus without showing severe illness themselves. From there, humans can become infected through contact with infected animals, including bats, chimpanzees, gorillas, monkeys, forest antelope, and porcupines, often through hunting, handling, or consuming bushmeat. When this jump from animals to humans occurs, it is called a zoonotic spillover event. Research from the University of California, Davis, published in 2023, has suggested that these spillover events may be increasing in frequency. The likely reason is environmental change. As deforestation continues and human settlements expand into previously wild regions, contact between humans and wildlife becomes more common. This creates more opportunities for viruses that normally exist in animal populations to cross over into humans. It is not a sudden new phenomenon, but a growing risk shaped by environmental pressure over time. Outside the body, Ebola does not survive indefinitely, but it is still resilient enough to remain dangerous under certain conditions. On dry surfaces at room temperature, the virus can survive for several hours. In wet environments or bodily fluids, it can persist significantly longer. This is why infection control in medical settings is so strict, requiring protective clothing such as gloves, gowns, masks, and face shields. Even small lapses in protection can create risk in high exposure environments. Once Ebola enters the human body, the infection does not cause immediate illness. There is an incubation period, typically between 2 and 21 days, during which the person feels completely normal and shows no symptoms. On average, symptoms begin to appear around 8 to 10 days after exposure. During this incubation period, the person is not contagious, which is an important distinction because it allows time for contact tracing and isolation strategies to be effective when applied quickly. However, once symptoms begin, the situation can change rapidly. The virus initially targets key immune cells known as macrophages and dendritic cells. These cells normally act as the body's early defense system, identifying and responding to infections. In a healthy immune response, they detect threats and help coordinate the attack against invading pathogens. But Ebola disrupts this system in a very specific way. Instead of being destroyed by these immune cells, the virus infects them and uses them as carriers. These infected cells then transport the virus throughout the bloodstream and lymphatic system. effectively helping the infection spread deeper into the body instead of stopping it. It is a form of immune system manipulation that turns the body's own defense network into a delivery system for the virus. This mechanism becomes even more concerning when we consider aging. As people get older, the immune system naturally changes in a process known as immunosenescence. This is the gradual weakening and restructuring of immune function over time. One of the most important changes is the reduction in production of naive T cells, which are responsible for recognizing new and unfamiliar pathogens. Research from the National Institute on Aging has shown that after the age of 70, the body can produce up to 50% fewer of these critical immune cells compared to a healthy younger adult. This means that when a new virus like Ebola enters the body of an older individual, the immune system is slower to recognize it, slower to respond, and more likely to become overwhelmed during the early stages of infection. This is one of the key biological reasons why older adults face higher risk during severe viral outbreaks. As the virus continues to spread, it begins attacking the cells that line blood vessels, known as endothelial cells. This damage leads to leakage in the vascular system, causing fluids to escape into surrounding tissues. At the same time, blood pressure drops and the body's clotting system becomes unstable. In some cases, this results in a condition called disseminated intravascular coagulation, where blood clotting becomes dysregulated, forming clots in some areas while failing to clot properly in others. This is where Ebola gains its most feared reputation for causing internal bleeding. Symptoms can include bleeding from the gums, eyes, or other areas, but it is important to understand that this dramatic bleeding does not occur in every case. In fact, it is seen in only about 30 to 50% of patients. The more common progression involves severe flu-like symptoms at the beginning, including high fever, fatigue, muscle pain, headache, and sore throat, followed by vomiting, diarrhea, rash, and eventually organ dysfunction. By the time organ failure begins, the virus has usually been active inside the body for several days, silently progressing, while the early symptoms appear similar to many less severe illnesses. This overlap in early signs is one of the reasons Ebola can be difficult to identify immediately without proper testing, especially in older adults who may already experience similar baseline health issues. To understand how serious this progression becomes, it helps to look at real outbreak data rather than abstract descriptions. During the 2018 to 2020 Ebola outbreak in the North Kivu province of the Democratic Republic of Congo, which was later recorded as the second largest Ebola outbreak in history, with more than 3,400 confirmed cases, medical teams began noticing consistent patterns that were especially relevant to older patients. These observations were not theoretical. They were based on direct clinical monitoring in treatment centers operating under extreme pressure. One of the most important findings was that patients over the age of 60 often presented differently in the early stages of infection. Their fever response was sometimes less intense than in younger patients, which might sound like a mild or even positive sign at first, but in reality, it created a diagnostic problem. A lower fever could mask the severity of infection and delay recognition of Ebola, especially in settings where older adults commonly experience fatigue, dehydration, or gastrointestinal issues even without infection. As a result, diagnosis was often made later in the disease progression, reducing the window for effective supportive care. Once diagnosed, the progression of illness in older patients also tended to be faster. Their bodies moved from early symptoms to severe complications in a shorter period of time compared to younger adults. Clinicians working in the field reported that this acceleration made treatment planning more difficult because the disease was not following the same predictable timeline seen in other age groups. This is one of the reasons why age is now considered an important factor in outbreak response strategies. Dr. Jean-Jacques Muyembe-Tamfum, one of the most respected virologists in Africa and a scientist who has studied Ebola since the original outbreak in 1976, has emphasized that supportive care is one of the most important factors in survival, particularly for older patients. Supportive care does not mean curing the virus directly, because there is no simple antiviral solution that stops Ebola instantly. Instead, It focuses on maintaining the body's stability while the immune system attempts to respond. This includes careful management of hydration, electrolytes, oxygen levels, and organ function. The idea behind this approach is simple but critical. Ebola places extreme stress on the body, and survival often depends on whether the patient can be kept stable long enough for their immune system and medical interventions to gain control over the infection. In older adults who may already have reduced physiological reserves due to age related changes, this supportive window becomes even more important. Now, shifting from past outbreaks to the present situation, it is important to understand that the current global health concern is not hypothetical. The World Health Organization has declared a public health emergency of international concern in response to a new outbreak involving the Ebola Sudan strain. This classification is the highest level of alert issued by the WHO and signals that the outbreak has the potential for international spread and requires coordinated global action. What makes this situation particularly concerning is that the Ebola Sudan strain differs from the Zaire strain that caused the West African epidemic. While a vaccine called Ervebo has been developed and successfully used against the Zaire strain, it does not provide protection against the Sudan strain. That means the primary tool that helped control previous large outbreaks is not applicable in this specific case. At the moment, there is no fully approved vaccine for the Ebola Sudan strain. Several candidate vaccines are currently in accelerated clinical trials, and research efforts are ongoing, but none have yet reached full regulatory approval for widespread use. This does not mean there is no hope or no progress, but it does mean that prevention and containment rely heavily on non vaccine measures for now. This is why public health systems are focusing on rapid identification, isolation of cases, contact tracing, and strict infection control procedures. These methods have been proven effective in previous outbreaks when applied early and consistently. However, their success depends heavily on speed, coordination, and public cooperation. Before continuing further into prevention strategies and what individuals can actually do in practical terms, it is worth acknowledging the emotional weight of this topic. Discussions about infectious disease can easily create fear, especially when the word emergency is involved. But the goal here is not fear, it is understanding, because informed decisions are always more effective than reactions based on uncertainty. If you are still following this closely, it likely means you are trying to make sense of a complex and serious health issue rather than avoiding it. And that matters because awareness is the foundation of effective response. In the next part, the focus shifts from the science and outbreak data to what can realistically be done at the individual and community level to reduce risk, especially for older adults and families concerned about vulnerability. Now, we reach the most practical and important part of this discussion, because understanding a virus is only useful if it translates into real-world protection. Ebola, despite its severity, is not a virus that spreads casually in everyday environments. Its transmission depends on direct contact with infected bodily fluids, which means prevention is not about fear or isolation from society, but about awareness, hygiene, and avoiding specific high-risk situations where exposure is possible. The most effective preventive step for the general public is straightforward. Avoid travel to regions where active outbreaks are ongoing. This is not about panic, but about risk reduction, especially during periods when transmission chains are still active and containment is not yet complete. For people who do not work in healthcare or outbreak response, this single decision significantly lowers any realistic chance of exposure. Another key preventive measure is avoiding contact with wildlife products from affected regions, particularly bushmeat. As discussed earlier, Ebola can originate from zoonotic spillover events involving animals such as bats and other forest wildlife. Limiting exposure to these sources is an important barrier between animal reservoirs and human infection. Public health systems have repeatedly emphasized this point because many early outbreak cases begin with animal to human transmission rather than human to human spread. Basic hygiene also plays a major role in reducing risk. Frequent and thorough hand washing with soap and water for at least 20 seconds has been shown to significantly reduce transmission of many pathogens, including those spread through surface contamination. Research from Imperial College London has estimated that consistent hand hygiene can reduce surface to mucosal transmission risks by up to 85%. While Ebola is not primarily a surface spread virus in everyday environments, hygiene becomes critical in any situation where contamination is possible. For older adults, there is another layer that is often overlooked in public discussions, and that is baseline immune and nutritional status. The body's ability to respond to infection is not only determined at the moment of exposure, but also by overall health leading up to that point. A 2022 meta analysis published in Frontiers in Immunology found that individuals with deficiencies in key nutrients such as zinc, vitamin D, and selenium had significantly worse outcomes in Ebola infections, with mortality rates increasing by approximately 28% compared to those with adequate levels. This is important because nutritional status directly influences immune system performance. Zinc, for example, is essential for immune cell development and function. It supports hundreds of enzymatic processes in the body and plays a key role in how immune cells replicate and respond to threats. After the age of 65, the body's ability to absorb zinc from food declines, which can gradually reduce immune efficiency if not addressed through diet or supplementation. Vitamin D is another critical factor. It is involved in regulating immune responses and activating innate immune defenses. Studies have shown that vitamin D deficiency is linked to higher susceptibility to infections in general, and older adults are particularly at risk because the skin becomes significantly less efficient at producing vitamin D from sunlight with age. In some cases, production can drop by as much as 75% compared to younger individuals, especially in those with limited sun exposure. While these nutrients do not prevent Ebola on their own, they contribute to a stronger baseline immune response, which can be important in determining how the body handles severe infections. The concept here is not about single solutions, but about overall resilience. A body with adequate nutrition, stable chronic conditions, and better physiological reserves is more capable of coping with extreme stress. This brings us back to the real case of Gerald, the 67-year-old man from Uganda who survived Ebola during the 2022 Sudan strain outbreak. His case was carefully documented by medical teams working in the region. What stood out was not any experimental treatment or extraordinary medical intervention, but rather his underlying health profile. He was physically active, had no major chronic conditions such as diabetes or hypertension, and maintained adequate nutritional status, including vitamin D and zinc levels. These factors are not guarantees of survival, but they contribute to how the body responds under extreme conditions. His recovery highlighted an important point that clinicians often emphasize. Outcomes in severe infections are influenced not only by the pathogen, but also by the patient's baseline health before infection occurs. As we look at the broader global picture, it is also important to address risk in perspective. For most people living in regions with strong healthcare systems, the risk of widespread Ebola transmission remains low. Hospitals, surveillance systems, contact tracing, and isolation protocols are designed specifically to contain viruses like this before they can spread widely. However, global travel means that no outbreak is entirely isolated, which is why international coordination through organizations like the World Health Organization is essential. History has already shown how quickly a virus can move across borders if early detection fails. The 2014 case of Thomas Eric Duncan, who traveled from Liberia to the United States during the incubation period, demonstrated that geographic distance alone does not eliminate risk. While the outbreak in the U.S. was contained, it required immediate response, strict protocols, and significant medical resources to prevent further spread. This is why global health alerts matter, even for people far from the outbreak zone. They are not predictions of inevitable spread, but early warning systems designed to trigger faster response, better funding, and coordinated containment efforts before situations escalate. Bringing everything together, Ebola is a virus that spreads through direct contact, not through the air. It has a relatively long incubation period, which allows for detection and containment when systems are functioning properly. Its severity comes from how it disrupts immune function, damages blood vessels, and places extreme stress on the body. Older adults are more vulnerable due to natural changes in immune function and the presence of other health conditions. At the same time, prevention is not abstract. It is based on practical steps: avoiding high risk regions, maintaining hygiene, ensuring nutritional stability, and managing chronic health conditions effectively. These are not extreme measures, but consistent habits that strengthen overall resilience. And perhaps the most important takeaway is this: age increases vulnerability, but it does not determine outcome on its own. Health is not defined by a single factor, but by a combination of long term choices, biology, and timely medical support. The case of Gerald illustrates this clearly. His survival was not luck alone, but the result of a body that was maintained in a stable condition over time. If there is one final message to take from all of this, it is that knowledge is the most practical form of protection. Not panic, not misinformation, but clear understanding of how risk actually works. Because when you understand the mechanism, you are no longer reacting blindly, you are responding with awareness. And that is where real safety begins.